Let me explain how WebHelp works with labs. I'm going to give data that is not correct. So let's say I measure the first thing, I use my electronic balance to find the mass of a single dime. So you should have found something different than this. I'm going to say, well, when I did it, I found it to be 3.7 grams. I hope your number was not this. But I'm just going to use this as an example so I can show you how to do this without giving you the answers. So the first question then is, how many significant figures is this? Well, I have 1, I have 2. Even if that's a 0, since there's a decimal, what I would say then is I have 2 significant figures. Now what I'm going to do is I'm going to use my electronic balance to get this conversion factor. 7 dimes equals how many grams? Well, I put it on there, and let's just say when I did it, what I got was 25.7. 25.7 grams. Now what I want to do on number 3 is it says I want to use my conversion factor to calculate the mass of 1 dime. In other words, I'm going to start with 1 dime and I'm going to convert it. So what I'm going to do is I'm going to say, alright, I have 1 dime, and I don't want dimes, so I put dimes in the basement. I'll just use D for dime. And I'm going to say, alright, what I just found up above was this. And I want to convert dimes rather into grams. So I'll look up here and I'll say, well, what I've got here is 7 dimes. So I'll put 7 for dimes. And then it says it equals 25.7 grams. So where it says grams, I'm going to say 25.7 equals. Now when I calculate that out, my calculator is going to give me a whole bunch of digits. My calculator is going to go like 3.67, 3.671, 428, blah, blah, blah. And what I'm going to do is I'm going to look at it and say, well, I have 3 significant figures in this measurement. 1, 2, 3. So I'm going to write the answer to 3 significant figures. So I'm going to record this as 3.67. Now it says below here, you should round your answer to as many significant digits as your initial one. So there is. Now I have 3 significant figures. By the way, I forgot something. I have to put a gram. Remember, you always have to put units. So here where it says include units on all answers, that'll be true all year. Never just say 3.7, say grams. Never say 3.67. If it's grams, you've got to learn to write grams. Let's try number 4. It says use your conversion factor to calculate the mass of 19 grams. So in other words, what I have to do is I have to use this conversion factor here. 7 dimes equals 25.7 grams. So I want to find the mass of 19 grams. So start with your 19 grams. In other words, I'm going to say 19 dimes. Did I say grams? I meant dimes. Now I'm going to multiply, draw my fraction line, put dimes in the basement. I want to convert it to grams, so I put that up above. Now I look up here at this conversion factor that you've generated yourself. And remember, your number is not going to be the same as mine. And I'm going to say, well, what I've got is 7 dimes, in my case, had a mass of 25.7 grams. Now that I got what I want up above, I say equals, and what comes out of my calculator is 69.7571. But remember, in all cases I want to convert for significant figures. So my conversion factor has 3 significant figures to it. Now this is a weird thing to think about, but is there any uncertainty in the number 19 when I count dimes? Generally speaking, when we count things, we assume infinite precision. There's no uncertainty here, so this does not really have 2 significant figures. It has infinite significant figures because I know with infinite precision it's 19, it's not 18, and it's not 20. I counted those rascals. But this I measured, so my uncertainty starts when I get 3 digits out. That's the idea of significant figures, and one of the reasons you're doing this lab. So I'm going to round this to 3 significant figures. I get to keep the 6, the 9, the 7. Since this is a 5, remember, if the number you're not keeping is 5 or more, you have to round up. So I'm going to make this 69.8 grams. And remember, that's not what you're going to get because you have a different mass for yours than I have for mine. Now, for number 5, you're just going to go ahead and find what you have. So let's just say I did it and I got, oh, I don't know, let's just say I got 70.2. The point here is I just want you to compare. How did you do compared to your prediction? Hopefully you got pretty close to it. Well, let's just move this up a little bit. Okay, so as I was just saying, so what you're going to now is you're just going to take your value here, which was 70.2. Well, look what I did. I forgot to put grams. Arg. Don't do that. You've got to include your units. Okay, how far off was my prediction? I'm just going to take my value, 70.2, and I'm going to take away the predicted value, which was 69.8, and that's going to give me 0.4 grams off. So in my case, I was off by 4/10 of a gram. I just want to know how far off you are. Hopefully not off by much. Now, this next one, it says, what is the mass of the dimes in Mr. Sampson's container? Now, I'm going to put a number, again, that's not real. I'm making this one up. Let's just say that what I came up with was 419.5 grams. Now I'm going to remember my grams this time. So what you would do is you go to the front of the room and you've measured this value here. This is what I had in my container. It was something different and a bit less than that. But still, this is the process you'd use. So now what I'm going to do is I am going to use my conversion factor now to find the number of dimes in my container. Now my conversion factor is the one up above. So what I do is I'm going to look back up because I forgot what it was. Oh, my conversion factor is my conversion factor is that 7 dimes is 25.7 grams. 7 dimes equals 25.7 grams. So let's just try this then. Alright, I hope I don't forget that. I probably will, darn it. Okay, so what I'm going to do is this. I take the mass that I found for Mr. Sampson's dimes. Hopefully what you found was not this value. This is not how many grams there were. I had quite a few less than that, but this is the process. You had grams, and I want to convert that into a number of dimes. So what I'm going to do is I'm going to multiply by a fraction. I'm going to put grams in the basement and dimes up above. And what I found was had 7 dimes with a mass of 25.7 grams. Now what's going to happen is grams are going to cancel out and leave me with dimes. So when I put this in my calculator, I'm going to say 419.5 times the top divided by the bottom. And when I do that, what I come up with is 114.26 dimes. Well, clearly you can't have 2.6 dimes, so I'm just going to round this to the nearest dime, and what that gives me is 114 dimes would be my prediction. Now, I like this next question. If I want a ton of dimes, how many dollars is this? So I have to have a few conversion factors of this. First of all, I'm going to start with 1 ton, and I'm going to convert that into dollars. So I need a few conversion factors. One thing I need to know is that 1 ton equals 2,000 pounds. That is on your conversion factor sheet I gave you that day. I would need to know that 1 kilogram equals 2.2 pounds. And I'd also need to know that 1 kilogram also equals 1,000 grams. Armed with that, I'm ready to convert. So I'm going to put ton in the basement, and I'm going to put pounds up above. I'm going to put, I don't want pounds, so I put them in the basement. And I am going to put kilograms up above. So one of these is, no, 2.2 of these is one of these. And then I put kilograms in the basement. and I'm going to say 1 kilogram equals 1,000 grams. That's a G. And then I'm going to put grams in the basement. I don't want those. I want dollars, but what I'm going to do right now is I'm going to use my conversion factor. I'm going to say I can convert grams into dimes because I know that 25.7 grams, my conversion factor, which is different from yours, equals 7 dimes. And I don't want dimes, so I'm going to put dimes in the basement. And I'm going to say 10 dimes equals $1. Now I'm going to start with 1 and multiply by the top, divide by the bottom, multiply by the top, divide by the bottom, multiply by the top, until I get my answer in dollars. Alright, we're going to find that the back side is a lot like the front, so I'm going to give you data that's not real. So let's just say I count drops into my graduated cylinder, and what I find is that 18 drops equaled 1 milliliter. Then I have a conversion factor I can use, so now I'm going to use that to find the volume of 70 drops. So this is the value I'm going to start with. So I say 70 drops, and I don't want drops, so I put them in the basement. I want milliliters, so I put it up above. And I guess I should point out that volume is measured in milliliters. And I would say that 18 of these equals 1 of these. So using the data that I had, using the conversion factor that I had, I would have come up with 3.88888888. And since I need to convert that to, this is not how many significant figures I have because I counted it. This is how many significant figures is because that's what I had to measure. So I know it to 2 significant figures, so I'd have to record my answer to just 2. So what comes out of my calculator is 3.888888, and so on. I get to keep 2 of those. So I'm going to keep the first one, the 3, the second one, the 8. This is 5 or more, so I round it up. I would record this then as 3.9 milliliters. So the next thing is I actually measure what it was, and let's just say when I did that, I came up with 3.7 milliliters. And then, so for question 13, how far off was I? Well, if I measured 3.7 and I predicted 3.9, that means I'd be off by 0.2 milliliters. I just want you to see how close you got. I think it's kind of interesting. And for this next question, really, all I want you to do is I want you to think about what kept you from getting the exact same values. Why was your measured value not the same as what you predicted? It could be things like how well were you able to measure, were all the drops the same size? I want you to just start thinking about what are some of the things in any given investigation that keep your predictions from being what you actually end up measuring. Alright, now I'm going to use my conversion factor to find the volume of 1 drop of water. So what I'm going to do is I'm going to start off with 1 drop. I don't want drops, so I put drops in the basement. I want to convert it to milliliters, which is the unit I use for measuring volume. And when I found my conversion factor showed that 1 milliliter was equal to 18 drops. I better double check that. Is that what yeah, that's what I found. Okay. Alright, so now what I'm going to do is I'm going to go ahead and I'm going to multiply 1 times 1, that's easy enough, and then divide by 18. And what that gives me is 0.055555 repeating. But the thing is, I'm limited in my initial measurement to 2 significant figures, so I have to round this to 2 significant figures. So remember, I start over here, I go through anything that's not 0, and this is what I start with. So I get to keep this 5 and this 5. Since this is 5 or greater, I'm going to round this up. And so in my case, not your case, but in my case, I would have 0.56 milliliters. Okay, this last one's a doozy. Let's go ahead and get started. So when you measure your sink in lab, let's just say, and I'm making these numbers up, that you found it was 36.2 centimeters by 28.4 centimeters by 44.7 centimeters. And when you did that, what you found it to be was 45955.17. I'm just going to leave that all in there for right now. So I'm going to convert that into, what I've got to do is, my task here is to convert that into how many hours. So ultimately I'm trying to convert this many cubic centimeters into hours. So I always start with the thing I know. So what I know is I have 45955.17, that's a 7 cubic centimeters. I don't like that 7. I don't want cubic centimeters, so I'm going to put them in the basement. And I'm going to say, you know what, I can turn cubic centimeters into milliliters using this conversion here. 1 cubic centimeter equals 1 milliliter. I got that from here. Now I don't want milliliters, so I'm going to put them in the basement. So I'm going to multiply, draw a fraction line, put milliliters here. Now I have my conversion factor from up above, where I can say 1 milliliter, 1.0 milliliters equals 18 drops. Now I don't want drops, so I'm going to put drops in the basement. And here I'm going to look at what I was told in this problem. It says it drips once every 3 seconds. So essentially that's saying that 1 drop equals 3 seconds of time. That's basically a conversion factor. The two equal each other. So I'm going to say 1 drop, 3 seconds. I don't want seconds, so I'm going to put seconds in the basement. I'm going to turn seconds into minutes. In this case, well, in all cases, actually 60 seconds equals 1 minute. I don't want minutes. I was asked to find hours, so I'll put minutes down here, and I'll put hours up above. 1 hour equals 60 minutes. So now what I have to do is I take this number here and say this times the top divided by the bottom 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 equals. And when I do that, what comes out of my calculator, and remember yours is going to be something quite different, is 689.327 hours. But I'm going to limit myself to 3 significant figures here. So I get to keep these 3. That one is less than 5, so I'm going to record my answer as 689 hours.